All right, well, again, welcome everybody to Reducing Occupant Exposure to EMFs in Residential Construction. This is part 2, avoiding alternating currents and magnetic fields. This course is approved for continuing education, GBCI, AIA, HSW, CGP, GCP, AIBD, and may be relevant for your state-based design or contractor license. Today I'm your host and moderator. My name is Brett Little, and I am the Executive Director of the Green Home Institute. The Green Home Institute is a nonprofit that exists to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. We got to thank our Platinum Plus sponsor for 2016, Andersen Windows and Doors, and check out Renewable by Andersen for all your renovation needs. And then our education sponsors, Cake Systems, Panasonic for all ventilation systems imaginable, even some new duct-free ventilation systems they're working on. Certainty by St. Gobain, they've got a drywall product that eats formaldehyde right out of the air. You can reach out to them about that. And then Warm Board for your heating and cooling non-duct alternative needs. If you support greener homes, become a member, support the movement, get discounts on free education, or free education and discounts on green certifications for your projects. And then also check out our new Certified Green Home Professional series. This session may be a part of that series. You get the latest in green building science, and you can take all of your courses on demand, online, just in time, and you can go pro by certifying an actual project. Check out more about that on our website. All right, so today I'm really excited to introduce our speaker, Spark Burmaster, with the building biology environmental consultant and a electromagnetic radiation specialist. But before I do that, I'm also going to introduce our overall series host, Orem Miller, who's also a certified building biology environmental consultant and electromagnetic radiation specialist. I'm going to hand it over to Orem for a second, who will talk to you a little bit about this series and then also introduce his colleague Spark. So take it away, Orem.
Thank you, Brett, and good day to every one of you. Thank you for attending this seminar. I was contacted last summer by Brett. He asked me to put together this webinar on the concept of electromagnetic fields as it pertains to building construction and remodeling. All of us who are on the panel have had extensive experience with this over the years as practicing building biologists. And so I put together a team of colleagues, including Spark Burmaster, who was one of my 2 teachers 12 years ago and a colleague of mine now when I lived in Minneapolis, and he's there in Wisconsin and near the Twin Cities as well, comes up there quite often where he grew up and attended the University of Minnesota Electrical Engineering program. But Spark is a building biologist, and he's been on the board of trustees, board of advisors of the Institute for Building Biology and Ecology, which promotes the concepts of building biology from Germany, as brought to this country by Helmut Zia, who passed away 3 years ago. But for 25 years or so, he oversaw the formation of the Institute, the International Institute for Biobiology or Building Biology and Ecology in the United States. So that is the organization that has trained and certified all of us. So we put together this team and had a seminar which you can look at and listen to online by going to the Green Home Institute website and then click on Learn, then CE Webinars on Demand, and then you scroll down to the particular series that this is part of, which is Reducing Occupant Exposure to EMFs in Residential Construction. So we've already had the introductory webinar. This is the second in the series. I will be conducting the next one on electric field EMFs. Then we'll have another one that will be presented by Damon Coyne, who's a building biologist and electromagnetic radiation specialist in St. Paul, Minnesota, on radio frequency electromagnetic fields. And then the last one of the focusing on the individual EMFs will be Frank DiCristina, who's also a building biologist, a certified building biology environmental consultant, and electromagnetic radiation specialist in Bloomington, Minnesota, just outside of Minneapolis. Then we'll have one last one where we will recap everything and put it all in perspective for you. But we're giving you as much information as we can that's relevant to your work as architects, builders, electricians, home inspectors, so that you can put this knowledge into practice and understand how it impacts those clients of yours who are either electrically sensitive, which is the primary group of people we work with, but also the general public, to help make their homes safer, to reduce the risk ratio for exposure to these fields. So for more information on all that, you can go to the Green Home Institute website and listen to the archive of that initial presentation where each of us had 10 minutes to introduce the type of EMF that we're going to be addressing in more detail. So let me introduce my colleague and good friend Spark Burmaster, who will educate you and enlighten you for the next 45 minutes or so, followed by questions and answers where all of us on the panel will have a chance to weigh in with answers in addition to Spark doing so. He's going to tell you about magnetic fields, magnetic field EMFs in great detail. Spark had his beginnings in EMF mitigation as a consultant for Organic Valley in Wisconsin, developing protocols to mitigate stray voltage on dairy farms, which is something that he's an expert in. He installed aeromotor water pumping windmills throughout the upper Midwest. He's also a founder of the Midwest Renewable Energy Fair, and he presents an electromagnetic exposure workshop for them annually, and he also teaches for the Building Biology Institute. His website is www.e-options.info. So without further ado, please welcome Spark Burmaster.
Okay, thank you, Arm. Okay, so we're gonna go here, and we're as the goal here. We get to the next page here. Come on. Do I have control? There. Next page. Okay, so this is sort of my one-page summary of the whole electromagnetic exposure issue, where we have magnetic fields, electric fields, radio frequency, and smart technology, all of which will be addressed, in further seminars. We're just focusing on magnetic fields. All right, so at the end of the session, this is what we're going for. At the end of the session, we can come back to this page and we get to the end. But here, a little clarification on the objectives of this seminar, as I'm assuming that this is targeted towards architects, contractors, and electricians, and what specifically should they be doing, which is basically, in a nutshell, is to make the electrical system perfect. And so anyway, so the general public can also learn from the issues and what's asked for. And so then after this seminar, these three classes of people will have specific things to do, and they can help people by eliminating magnetic field exposure. And third, this issue of helping the welfare, we're also addressing the issue is that there are two types of people that we deal with. Those that are electrically sensitive and those who don't want to become electrically sensitive. And we want to specifically address the issue when either of these two type people comes to any of the above and says, I need help, that we do not want those three people to say, I don't know nothing about that issue, go somewhere else. You say, either I'm an expert in issue and I can help you, or I can help you find somebody to do it. But basically, that's the main frustrating thing with electrically sensitive people, is finding anybody that's willing to listen to them and willing to help them. And we want to specifically address that problem. All right, so then these are the two types of issues, there are two types of sources that we're not going to talk about today, which is the issue of appliances, and which is the issue is you don't need meters, you just know that gadget on your table, if it's electrical, it's putting out fields. But also those appliances are outside the scope of electricians. Those are things that get plugged into the walls after the electrician leaves, and he has no control over those. And then the other issue is this external sources, such as this transmission line right next to a house is going to have big magnetic fields, and there are some things we have been known to do about these issues, but they're extremely expensive and not practical. Right, so then this is our one science physics diagram, and it shows that whenever we have a source of electricity sending power, these red lines going down the yellow wire, is it produces the black magnetic field lines. And so then the magnetic field lines are around all the wires, and so if you have a separation of conductors, then between the two conductors the magnetic fields add. And then if these two wires are next to each other, the magnetic fields cancel each other. And so if the wiring is perfect, so that all the wire that goes out one conductor returns in the same cable, then the cable puts out minimal magnetic fields. And so then that's the assignment of all the electrical people, is to make sure and absolutely verify that all the current flows exactly where it's supposed to flow and not somewhere else, and there's zero current on the grounding system. Basically, we want the houses to be hospital-grade electrical systems. Okay, so the wiring errors, and there's two types mainly of wiring errors, and we're defining wiring errors as anything that causes the electricity to flow somewhere where it's not supposed to flow. And so the two main problems are neutral to grounding system somewhere after the start of the service, or neutral to one circuit contacting the neutral of another circuit. And these can be inadvertent or intentional. And the main intentional one is the metallic water service supply pipe, because the electric code as presently written requires you to connect to the metal water service supply pipe. And so the only real solution to that is do not have a metal water service supply pipe. If you do not have a metal water service supply pipe, that whole issue goes away. Okay, so and then here, okay, we're all the way down to here. All right, so this is what wiring errors look like in the real world. Right, so, and this is also specifically why we're not talking about the issue of addressing wiring errors in existing buildings, is because when you get into that whole field, it's a whole snake pit. We also call it as Uncle Fred wiring, and Uncle Fred is just incredibly ingenious about weird ways he can come up to wire up houses, and you finally figure it out and fix the problem, and you say, I have never thought anybody would figure out how to do it that way. And so this is an example of multiple circuits in a single box, and they just took all the neutrals and put it into one wire nut. And so the fix in this particular box was just to figure out which of the wires are associated with the separate circuits and just separate the neutrals. So it's an easy fix once you get to this box and know where that problem is. This is, I don't know what this thing is. He's got a ground wire going to a neutral. I don't know what weirdness that is. And this is, they installed, and this is a ballast. And then in there is that they just squash down the ballast and pinch the neutral wire. And so then there it is. Now we got neutral in the grounding system. And then since all that metal is connected to all the drop ceiling metal, so when you have this case in here, then all the metal and all the drop ceiling metal has current on it, producing magnetic fields. So just having this one little mistake here on the connection next to this ballast can cause magnetic fields all over the room, or for that matter in other places in the building. That's one of the issues with all these wiring errors, is one wiring error one place can cause magnetic fields in a whole bunch of different places in the house. And so that's why when you're looking for these problems, you cannot use a Gauss meter to search down the problems, because the magnetic fields could be anywhere caused by anything. And all the investigation for finding wiring errors is done just with clamp-on ammeters. Okay, so this is an example of the circuit having to do with a wiring error. Here's our refrigerator. And so if there's a neutral to ground in the refrigerator itself, which would be beyond the responsibility of the electrician, or a neutral to ground in the outlet, which would be the electrician's responsibility, is the current would come out the hot wire, go through the motor, and then once it got to the low side of the motor, you would see two paths. One path to go back to neutral where it's supposed to be, and the other path is to go out the water service supply for the ice maker, go down to the water pipes, and once it's on the water pipes, it can see a multiple other multiple other paths, and all of those paths are going to be giving off magnetic fields. And so this is an example of one little error in one place in the house can produce magnetic fields all over the house. So therefore, you could not find this problem, using a Gauss meter. You have to just examine the electrical circuit. So this is an example of Uncle Fred wiring. But apparently in some parts of the country, it's a common way of wiring, which is specifically the use of 14-2 for the travelers, three-way switching rather than using the correct 14-3. And in this case, Uncle Fred came in there, and he had a light at the top of the stairs, and he had a switch. And then they said, Fred, can you put in a three-way switch? And he said, sure. And he just ran 14-2 down to here. And, now I don't have any hot. So he gets the hot from here. So the current comes up to here, goes through the light, and returns this path. And so now he's got magnetic fields all over the house just because he faked that three-way switching. And this issue of using 14-2 is a common problem. All right, so then the next issue is the configuration of wiring in panels. And what we're doing here is two things. Is we want to eliminate the magnetic fields coming from the panels itself, and we also want to make the panel serviceable, so if there are any problems, you don't have to try to figure out the panel like a Chinese jigsaw puzzle to try to figure out how to work in the panel. If everything is laid out decently, it's easy to fix. And so the criteria are all the hots and neutrals are accessible for maintenance. Right? All the branch hots and neutrals are labeled, and all the corresponding hots and neutrals are kept together. And this is as originally found. And then we can see that here's all our neutral wires down at the bottom here, so we get big magnetic fields, but also any given neutral wire down here, you don't know what circuit that's going to, so it makes it difficult to solve the problem. And then here's after configured. And this is a sub-panel, so there's a separate neutral and ground buses. And so we go hot, neutral, hot, neutral, hot, neutral, hot, neutral, and so it's a very easy panel to service. And this would be another panel, and it's extremely difficult to operate. Is one, the tie straps that serve no useful purpose whatsoever, and all they do is cause problems with the maintenance people. So no tie straps. And then it's difficult to find the corresponding hots and the neutrals. Again, we don't know which one of those neutrals goes to which hot. And the third problem is just the design of the panel. A good panel would have the neutral running all the way down, It would go hot, neutral, hot, neutral, hot, neutral, all the way down. So everything is identifiable. And so when you're laying out the panel, basically keep saying to yourself, this will be an easy panel to work on. If anything is inaccessible, we don't like it. All right, so then this is another bad example of a panel. There it is, a jumbled mess up in there. No human being can figure out how to work on this little jungle of wires out there. If you're trying to find neutral to ground errors, it's a pain in the hinder to work in that panel. All right, so anyway, and then also this issue of running the feeder all the way across the panel. We don't want to run across the panel, just invert the whole panel. Okay. Okay, so then this is the next issue, is the location of the service drop. So this is your worst case analysis of they locate the meter in the panel right on the other side of the wall from the maid bedroom. And we just see that so many times, even in these high-end houses. They stick that panel just right next to the, right next to the bed. And the ideal way, this house here is better, is because they have it on a garage wall. And this is even better, way away from the house. And we did this house here, and the main thing we would have done different on this pole that's out on a post way out in the yard is nowadays we face the meter away from the house specifically to address the issue of the radio frequency coming off of the smart meters. And so anyway, so the only thing I would have done different on this situation is I just would have put this meter on the other side of that panel so the meter was facing away from the house instead of towards the house. All right, So in this issue of measurements, is that the issue was basically the electrician does not need to measure magnetic fields. As that's the job for environmental inspectors who are tasked to find all magnetic field sources, and the electrician and contractors and everyone, the architects are only responsible for the building wiring itself. And and if you really wanted, and then ideally they would educate the people that they've done all the right things to do the new construction right, but you're not addressing the magnetic field problems unless they also being aware of what they install in the house. Or in the case of that bad refrigerator, is addressing the issue is if you put a bad appliance into the house, then the bad appliance can cause magnetic, which means the neutral ground in the appliance itself can cause magnetic fields all over the place. And so the electrician then has come out, if the client has their own Gauss meter and reports they get magnetic fields all over the place, and they call in the electrician to take care of it. If the electrician comes in there and he takes his clamp-on ammeter and measures current in the grounding system, proving there's a problem, then everything is good for everybody. If the house is designed right, with everything easy to be serviceable, it's very easy to track down problems with wiring if everything is laid out nice and accessible. That's the key word there, is accessible. Then it's easy to fix those type of problems. If the house is laid out like a snake pit, then it just makes it a big problem to find problems. All right, so and then also this issue of an inspector finds the current on the grounding system. If an inspector is called out and they wave around a Gauss meter and find magnetic fields, then the inspector is supposed to get out a clamp-on meter. And if they find current on the grounding systems, then in the ideal world, then that inspector could just call up the appropriate electrician and say, make the wiring system perfect. And by definition, if the wiring system is perfect, there's no current on the grounding system, and then the electrician is outside of the liability loop of dealing with magnetic fields. He's done his job as if there's no current on the grounding system. And when we're dealing with the electrically sensitive people, it's amazing, but it's only amazing the first time. But when you see it repeatedly in multiple people, then of course it's no longer amazing. But it's amazing how small amounts of current on the grounding system affect people. And so that's another angle we push on this whole thing, is that the electrician and contractors, or none of those people are supposed to be making any biological decisions. They're never supposed to come out there and say, well, that person is nuts. And they said, no, if they got electromagnetic issue, then you just do your job. Make the electrical system perfect. And you'll be amazed the number of times you make the electrical system perfect and the person says, the house feels quieter. And that's what you want to hear, is you've done your job, you've got rid of all that stuff. But then, of course, in the modern world, the real problem all that is all that radio frequency stuff that's still left in the room. But again, that's outside of the purview of the electrician, is all those appliances, the radio frequency appliances putting in there, which actually brings to the next issue of the whole smart house, is having all this embedded electronics inside the electrical system itself. And the recommendation for electrical sensitive people, it ain't going to work. None of that stuff is compatible with electrical sensitive people. If they want a house that's compatible with electrical sensitive people, it can't have any electronics embedded into the system, which includes also, that of course means things like light dimmers and all those other kind of things that now you show up in wire house wiring. And I wouldn't even have you wouldn't have the remote controls on for the fans and ceilings and any of that electronics. It just want a classically clean, old-style electrical system where all the wiring is just regular copper, not all kinds of electronics embedded into the electrical system itself. And then this issue with measuring and things is after all the wiring is corrected. Then you can get out And then if the wiring is all corrected as defined as having no current on the grounding system, then you know that the electrical system is not the issue. And if you're finding any other magnetic field still left in the house, then it's an appliance issue, and it's a power line next door, it's the water pipe under the street, it's anything but except the electrical system being the issue. And here's this issue of measurements. I mean, in fact, I did a training session for a big company that had nationwide offices, and they reported the issue of jittery computer monitors, you know, back in the days when they had CRTs. And we went out there and looked at a half a dozen offices, and every single time we found that the problem was wiring errors in the place that caused the magnetic fields, which caused the jittery computer monitors. And so he just summarized the whole session up with, he says, we quickly learned that the main thing we learned is we quickly set down the Gauss meter and pick up the ammeter and just treat the electrical system as that, an electrical system, and the electrician's assignment is to make the electrical system perfect. All the current flows everywhere. And somehow I think we missed a slide here because I was going to bring up another issue about way back when, about this issue is what can you do to test that. And the main way you want to test it is using the GFIs, because that's the other issue, is bad circuits which have neutral to grounds are going to trip GFIs. And so the quickest way to measure whether any given branch circuit is perfect is just to hook up the branch circuit to a GFI. If the GFI works, then the circuit is good. If the GFI trips, then you get out the clamp-on ammeter and you figure out where is the neutral to ground somewhere in the circuit that's causing current to flow somewhere, you know, where it's not supposed to be. And so that's the whole idea of this. What electricians do is that electricians are not required to be experts on magnetics and are not required to be experts on health. All the electricians are required to be experts on electrical systems. And the only instrument they really need is a clamp-on ammeter to verify that the current actually flows where it's supposed to be and not somewhere else. Okay, so and then we get down to here, and this our summary page, right? We want to verify there's no current flow. That's where the clamp-ons is, and you're going to use that clamp-on meter. And when we're dealing with these small currents, ideally you want a clamp-on ammeter that has a resolution of 1 milliamp. I mean, with electrically sensitive people, it's just amazing how tiny amounts of current can make a difference. And it doesn't make any difference how small the current, well, it does make, you know, it doesn't make any difference for the electrician or how much sense it makes that a tiny amount of current, you know, electricians normally deal in amps, and we're talking about messing around with milliamps. It doesn't matter, just fix it. And then the problem detected with the GFI, the correction and verification through the clamp-on ammeter, and then correctly locate and configure the panels, meaning that that's the main thing you want to do, is to make locate the panel and the meter and all that stuff away from the living area and configure it. So when the next person that comes in and you or any person that comes in to work on that panel later says, boy, I like this way this panel's laid out. Everything is accessible. Everything is identified. I can easily figure out what it is, and they're not have to spend half their time wrestling with trying to figure out the panel in the first place. And then there's a whole bunch of other problems that we're not dealing with today because that's beyond the scope of this, and one of the big ones is the HVAC systems. And one of the issues with HVAC systems is when they ground the 24-volt system at the compressor. Causes current flow all over the place, you got problems. And and then the cable TV is actually a cable TV person issue, but when you're laying out laying out the place in the first place, is you want to have the cable TV hit the house at the same place where the electrical service comes in, because that's where the cable TV is going to connect to the electrical. And if they have their system and connected to neutral to ground and the cable TV system, you're going to get current on the cable TV line. So if you have the cable TV hit the house on the opposite side of the house where the electrical system, then you're going to have a big source of magnetic fields all the way across the house on the cable TV line. And so on alternative energy systems, then when they really dived into the snake pit of exposure, because one is there's just electronics everywhere. And so, I mean, we're addressing that in a whole nother venue. We're addressing this alternative energy systems and electromagnetic exposure. And the main issue with alternative energy systems is, other than the fact that all the things may produce electrical noise that we don't want, which is going to be talked about in the dirty electricity, but the other issue with alternative energy systems is the grounding system. Is when you have multiple sources of electrical systems, then you have multiple grounding systems, and the absolute right way to be it is all those different grounding systems can only touch each other at one point to make sure you don't have any current on the grounding system. And it's just that it gets to be a complicated issue when you're dealing with alternative energy. So basically we recommend, if you're already an electrically sensitive person, don't have an alternative energy system. They're just too complex. And we're going to we're writing up that paper, come up with various things to do with alternative energy systems. But basically, again, it starts out with, is the grounding system has to be perfect. And when also we did talk about another little grounding system is just ground loops. Anytime you have a closed loop of metal, you can induce current on it. And including just we talked about having current on the water pipes. And so, I mean, we don't hardly have any copper water pipes anymore, especially in new construction, but that was an issue when they had copper water pipes, is just by the fact that it was closed loops of metal, you could induce current even though it was wired correctly. So, anyway, so when you get into the nitty-gritty of it, and then it gets to be a little more complicated, but if you're doing new construction, so you pretty much have control of what you're putting in there, and do a clean install and properly place things and make it easy to service, pretty much you've done your work, from the electrician's perspective. And then there's also the sociological issues associated with this. Is one of the problems we run into is bidding contracts, housing, and when you're building a new house, and then the contractor bids on it, and then which I think is an extremely poor way of doing it, because then the thing is that when things go wrong, it's expected that the contractor pick up the problems. And so if we're talking about doing extra things for electromagnetic, they kind of fall away from the wayside if the contractor is stuck with paying for the difference. And so that's another big sociological problem here, is who's going to pay for it. I mean, as far as I'm concerned, all the things I'm recommending there is just common sense wiring, and would require minimal extra money, but you still have to take time to do it. But as far as I'm concerned, even without the magnetic field issues aside, if you just ignore that whole issue of magnetic fields, everything I'm proposing makes good common sense to do. Make everything serviceable. Well, it doesn't make any difference whether it's a magnetic field or not. Having a good serviceable building is a good idea. And in fact, that's another issue these electric sensitive people run into, is to call up an electrician and then try to convince electricians that magnetic fields problems are causing health problems. And then the number two is to make the assumption that electricians should be experts on magnetic fields, neither of which are true. Electricians are experts on electrical wiring. And so the solution to that whole conundrum is that when they call up an electrician, then they don't talk magnetic fields, they don't talk health, they don't talk any of that stuff. They just say to the electrician, we want an electrical upgrade. We want you to come out here, we want you to go over the electrical system, and we want you to make it perfect so there is no current flow on the grounding system. And then that's something that electricians can deal with, because all he needs is clamp on ammeters and etc. And, you know, to me it's just a waste of time to say to the electrician, you have to believe in magnetic fields and you have to believe in health issues. And he says, no, all the electrician has to be is experts on how to make a perfect electrical system using all the common sense things that we've just described. All right, so now I guess, normally I do it in here on this other thing, on this types of grounding systems. And one of the problems with grounding systems is that in the whole definition of all the grounding, they use the word ground about 6 different ways in the electric code, and it's a confusing system. It's called electrical grounding system is confusing, when in the real world, if you get all your definitions straight and do all your things right, it's not confusing. And so one of the 2 main problems with talking about grounding systems is there's the concept of equipment ground and there's a concept of the system ground. And the equipment ground refers to the issue is it deals with there's a problem with the wiring or the appliance inside the house, and we want the equipment ground to cause a large amount of current to flow so that the circuit breaker trips out. So that's the purpose of the equipment ground, is to trip the circuit breaker if something goes wrong. The second system is called the system ground, which is when the grounding system touches the physical earth, and its whole purpose in life is to allow a path for lightning to flow to get into the earth. And it doesn't have anything to do with circuit breakers. And so the reason we want to hammer away and people have a clear understanding of grounding systems is because basically you get magnetic fields if you have too much grounding, and they get electric fields if you don't have enough grounding, which electric fields is what Orem is going to be talking about in the next session. And so this issue is that if the issue is current flow on the grounding system, you can't just go around and be snipping ground wires thinking, well, I stopped that current, I got rid of the magnetic fields. Well, no, you can't just arbitrarily cut grounding wires. Everything has to be electric code, everything has to be grounded. We just don't want it to be overly grounded where you've got ground loops, and so the ground loops is what causes the current, not the grounding system itself. And then on here, this issue on grounding and grounding terms is this is sort of a visualization of what we had talked about on that first diagram that showed the physics thing, is to show that here's our main panel, here's our sub panel, and I'm kind of assuming here that you can see my cursor. I don't know if that's true or not, but out here under this sub panel, you notice that neutral and ground are separated in the sub panel, and that's a big problem we see in houses, is just that single screw in there just causes current flow in the grounding system all over the place. And so anyways, the current is supposed to come out the hot and return to this neutral, and you notice that every path, everywhere, that whatever current is on the current going out is the same current on the current going back. So if you took your clamp on and clamped onto that cable, then you would see zero current regardless of whether there was loads on or not. In fact, that's another proof, if you have something like a basement, so you have access to the wiring, if you go down in there, you should be able to clamp on anything and everything, and it should say zero current. And then that's why the reason why you need that clamp on ammeter down to the milliamp range, Because I was working with an electrician one time, and he said, well, I got my regular clamp on here, and I go down there and clamp onto this, and this is 50 milliamps. He said, nothing. I said, well, this one here is 150 milliamps, and they said nothing, and etc., because his meter just wasn't sensitive enough. You have to have a clamp-on amp or digital multimeter combination sensitive enough to read these small currents, otherwise you just won't see the small currents. Just keep hammering away at our main themes. Is the assignment is the electrician is to make a perfect wiring system, and that's another issue that's going on, is with the proliferation now of the GFIs and the arc faults all over the place, and all of those things will trip out on wiring errors. So in effect, the electrician is forced into testing everything with a clamp on and making everything perfect, because in the modern day house with so many GFIs in the house won't work unless the wiring is all perfect. And and we're just advocating the issue is that you should put a GFI in every single branch circuit in the house in order to prove that it works. And then you got to get out your amp meter and fix it if it doesn't work. And then the other sociological issue is that the contractor has to provide the money. So when you're talking about bidding the house and etc., there has to be extra money available to do testing, to do verification, because under the present system it says lease costs, slam bang it together and hope to go. And no, we want to put it together, meticulously put it together, and everything has to be tested perfect, which sort of costs more money, and so they have to have that as part of the original budget, that that there's money available to do it right, and the objective is not to save every nickel you can on the electrical system. The goal is to make the electrical system perfect. So anyway, let's go ahead and go to the Q&A here. See where we're at. How are you going to do this thing now?
Yeah, great. So, thanks, Orm, for going through some of those questions there, but we definitely want to get some of them answered vocally here. And maybe we can start, let's see, with a question really about what you were talking about, Spark, in regards to the electrical wiring being perfect, and whether that is connected to code or if that is beyond the code requirements.
No. I mean, the code actually says to make it perfect, but there's flaws in the code. The main flaw being the requirement to connect to the water service supply pipe. And when you connect to the water service supply pipe, and if the water service supply pipe, then in the electric code is flawed in that it pretends that having a metal water pipe leaving the building, going all the way over and connecting into the electrical system is not an issue. And it is an issue. If you go over there and you clamp onto a water surface, I've literally had this inspector say, and he was a state electrical inspector, and I said, what happens, and I said, what's the issue with current flow on the water pipe leaving the house? And he goes, oh, I measured my house, and I measured, this is the electrical inspector himself. He said, well, no, I measured the current in my water service supply pipe, and I measured 4 amps of current, but it didn't bother me at all. And I go, well, that's not the question. The question is, what do you do with the people that it does bother them? And so that's the main flaw in the electric code. And of course, the way the solution to that is don't have a metal water service supply pipe, and that whole issue totally and completely dissipates. Disappears. And then if there is a metal water service pipe, there's other ways to deal with that, but it's just much more straightforward and much safer and much everything else under the sun if you do not have a water service supply pipe. But that's my main contention with the electric code, is that one single issue, and basically everything else is already in the code. Already the code says do not have current in the grounding system. The only flaw is they just define it as objectionable current, and so they leave it as an option, is you don't have to deal with objectionable current on the grounding system unless somebody objects. You know, and my take on it, no, you ought to make sure there's no current on the grounding system before you leave the building. But as long as you got that current in the water pipe to the neighbor in the issue there, that's sort of the 800-pound gorilla in the room. So
Spark,
anyways,
can I speak to this?
yep.
Okay, so Michael Clement asked a very good question here. Let me help elucidate this. What Spark taught us, and what I now help teach as a teaching assistant for the profession to our students, is that you can have two situations. You can have neutral to ground wiring errors in the circuitry in the house, and you can have current on the water service supply pipe under the front yard. You can have both of those situations, or you can have one or the other. Now, in a situation like you mentioned here, where you don't have any ground faults, meaning neutral to ground connections inside the house, causing these loops that Spark talked about, where some of the return current, this deficit between what goes, if 3 amps goes out on the hot, you want 3 amps to go out on the neutral in that circuit for every circuit when a load is on. But in a situation like a neutral to ground connection, you'll have 3 amps going out, and 2.5 comes back because half an amp gets onto the ground system and then comes back on whatever is the quickest and shortest route relative to resistance for that current to get back to the source, which is the panel. And the reason why this happens is because electric current will take all available paths to get back to the source, not just it takes the path of least resistance primarily, but not exclusively. And then if you take that concept within a house and extrapolate it to the whole neighborhood, you have a situation where you can have 8 amps coming into the building on the hot wires between the two legs, and you should have 8 amps going back, but you could have 7 going back because 1 amp is going on the grounding conductor to the metal water pipe and out the front yard on the metal water service supply pipe, and also the sheathing of the TV cable, by the way, is another but parallel path. These are parallel return paths, or parallel paths for return current to get back to the transformer from each house. And this metal water service supply pipe from each house that connects to a metal water main provides a network or a way in which return current can flow from each of those houses through each of the other houses to get back to the transformer. You're not metered for this. You're metered for what you use on the hot side, but this is a return issue. So I want to make that clear. And it's really important when Spark says that you don't want to have this. In certain parts of the country where you don't have frost, like in the southern tier of the country, the water service supply pipe is only 18 inches below the yard. And for those of you in the southern half of the country, your water meter for each house is out at the street, like where I live here in California. And so you can put a dielectric union out at the water meter, which is what many of these municipalities do. And we don't have this problem in half the cities here in where I live. And I asked the guys, why do you do this? And they said to stop the stray current, because when that flows on that copper pipe, it causes electrolysis because you have copper at one potential and the salts of the soil at another potential. And when people overwater their lawns, as they did before the drought we have, you had electrolysis and pitting and corrosion with little pinhole leaks of the water pipe under the front yard. And that means that the water pressure over the decades would drop. So to prevent that, they put a piece of plastic, either a dielectric union or a 1 or 2 inch nipple of Schedule 80 PVC at the water surface supply pipe on the house side of the meter out at the street in that pit there. And then you hardly measure any current whatsoever, and we don't have the magnetic fields that we're concerned about. And you can do that because you maintain the code requirement to have 20 or 30 feet of copper pipe under the front yard as a path for lightning to get into the earth in a strike, or for overcurrents of the electrical system in a dead short. So, there are many solutions for this.
Yeah, but to clarify is what the electric code people are allowed to do is the electrical people are not allowed to specify plumbing, and plumbing people are not allowed to specify electrical.
Well, we coordinate.
So the electrical code does not have the power to require a metal water pipe going out. All the electrical code says is that if the water service supply pipe is metal coming into the house, you have to connect to it. So don't have it metal, end of story. But but there's no requirement. That 10-foot rule is a bunch of foolishness. You're talking about the 10 feet of pipe qualifies a grounding system. All that says is that if the water pipe coming out of the building is 10 feet of metal, it qualifies as a grounding electrode. It doesn't say it has to be there. It just says if it's there, you have to use it. So don't have it there.
Well, when I was in Minneapolis, it was very interesting because there were two suburbs in northwest of Minneapolis.
But I don't know how much we want to talk on this one particular topic. So.
Well, it was just very interesting that in one city they said we switched over to plastic and we don't even allow copper anymore. The city right next to it said we're doing copper, we're not going to plastic, we don't allow, you have to use copper. So it depends on the municipality actually in that regard. There are workarounds. Spark has developed a workaround that was approved by the code inspector for the state of Wisconsin, which he can provide for any of you who want that, where you have water service supply pipes that are 4 to 6 feet deep coming into a water meter in the basement, and he can provide that a workaround for you if you contact him.
But the water pipe to the neighbor is the 800-pound gorilla in the room. If you have that source, that way overwhelms every other problem you got in the house.
Well, Spark, so this gentleman, Dan Brinkman, asks, what are the alternatives to metal water supply pipes that will meet plumbing codes? All I have ever seen is metal coming into a house, typically copper. Is the dielectric union we're talking about the answer? If you have copper water pipe already coming into the wall or the slab of a basement, you have to deal with it. And that's where your protocol was probably about the only answer that would satisfy code.
Yeah.
You want to explain it to people, how that works?
Well, this is a 1-hour seminar. I don't know how much you want to get into details on one particular issue when there's lots of other people asking questions. So
well. So far, according to the chat, the box here, that's the question that's at hand. And I should mention that we always hope that some of you who are listening to this now or as a recording will be inspired to consider contacting the building biology profession and consider taking the seminars that we have. Spark is one of the main teachers, Larry Gust, an electrical engineer here in Ventura, California, outside Los Angeles, and Rob Metzinger from Canada at Safe Living Technologies, and electronics technologist are the two main teachers, and Spark is a main teacher as well. So we hold the basic EMF seminars, or EMR, in electromagnetic radiation seminars, every August, every year. And then every other year, we hold the advanced seminar on EMFs that you take once you've successfully passed the basic seminar. They're 5 days each, and we have a group of teaching assistants. I'm one of them who help with the labs. So it's very intensive. There's a lot of information to cover, but we go over it again and again to help you understand it. So go to hbelc.org. It stands for Healthy Building Environmental Learning Center. So hbelc.org, and then click on seminars and certification tracks and contact Michael Conn, C-O-N-N, our executive director, for more information.
So where are we in these questions now?
All right, guys. Well, actually, we're at time here. Orma, we could probably answer one more if you see another one in here that you think is pretty good, relevant. Otherwise, all of you are welcome to contact Spark. I've got his contact information right here, and you can reach out to both of them and ask any further questions. Several people have asked, are there building biologists already in practice in the U.S. and Canada, and how do you find them? And the answer is yes. We have a whole network of certified building biologists around the U.S. and Canada, and worldwide, for that matter, trained by us and by our counterparts in Europe. So basically, go to the hbelc.org website, and on the right-hand side, you can scroll down to find an expert. I believe that's what it says, and you click on that and go to environmental consultants. And then when you see the table, if you click the state/nation tab on the top of the right-hand column, it resorts the column by state rather than alphabetically by last name of the person. And that way you can look for your state or a nearby state and find a certified building biologist who
help you out with the project. You can also contact any of us who are panelists on this and to help you. Damon, you're on, and Shayla, do you have any quick parting comments? You're on. Unmute your phone and just say hello and any comments you guys have.
None for me.
Yeah, I think Spark did an excellent job giving an overview of these main dynamics that we're seeing. As he said, there's lots of nuances, but I think he's done a great job covering the basics here.
Yeah.
And everyone should know that this is only the first of 3 more webinars where, so we're presenting each of the 4 types of EMFs are covered now in detail in 1 hour. So you just heard Spark's presentation on magnetic field EMF evaluation and mitigation. I will be presenting the next one in the series on electric field EMF evaluation and mitigation, which is honestly the most common and yet the least known EMF. I call it the unknown EMF, and it mostly affects the depth and quality of your sleep. So we'll be talking about that next time. The third one in the series is of specific discussions of the EMFs in detail will be Damon Coyne, who you just heard from, talking about radio frequency EMFs, and then Frank DiCristina, who's out on a job and couldn't be with us, will be talking about dirty electricity as the 4th one, and that gets into dimmer switches and all the inverters for solar panels that Spark alluded to. And then we'll have a recap for the very last one where we'll tie it all together and answer questions. And Shaylee Olson is a building biologist in Minneapolis who does a great deal of work with contractors in the Twin Cities, as does Damon and Spark and Frank. But Shaylee really focuses on probably indoor air quality as much as EMFs and works a lot with the construction trade, as you do as well, Damon.
All right, everybody. Well, we're going to start wrapping up here. I want to thank our instructor here, Spark Burnmaster, and then Miller Orem for interjecting and helping with some of our Q&A, as well as the rest of the EMF team here who will be presenting on some other courses that are available. Just real quick right before we wrap up, those of you looking for your continuing education credits who are listening here live, you can pick up a survey that'll be sent to you here shortly, if not already, and we'd love to have you fill that out even if you don't need CEUs. For those of you listening on demand, taking one of the courses, make sure to take your quiz after this, and you'll need to get a passing rate of 70%. Finally, on that note, we're really excited to be able to hand out a free tool that you can utilize, the Green Star checklist, where currently you can go down to the Innovation tab if you access this checklist, and you can see all of the what we call design for reduced electrical and magnetic fields, and you can see all the specifications. You can generate scopes of work and content for your contractors to bid on, and we're going to be upgrading this and creating its own special EMF reduction section within the program here soon with these folks who are, who initially started this and are going to be helping us upgrade it as well. So take a look at that at greenhomeinstitute.org/greenstar. So thanks for your time, everyone. This session will be available as well to watch over again. Make sure to reach out to Spark or Orem or your local building biologist to get you started on your next project. Enjoy the week.